Hey guys, I got asked to talk about the congruent stuff, and I have to admit this assignment right here is probably one of the most confusing assignments we've had so far. So I completely understand, and I'm going to tell you not to fret too much about it. We'll get through it, but they're making this a little bit more complicated than I think they need to. Okay, so we're just basically translating. They tell us, and again, just for marking senses, so you understand what the markings mean. When you see a single talk mark, that means those lengths are the same length. When you see one angle and one angle marked the same way, that means they're the same measure, and the two marks mean those are the same measure. So then basically what they're saying is they're going to take this triangle and they're going to map it onto that one using transformations. Now, you can't just rotate it. You're going to have to do a couple of things. You're probably going to have to rotate it, and then you're going to have to maybe, I don't know if I rotate it, if it'll end up exactly right on there. You might have to translate it, and then you might have to flip it. I don't really know exactly what they do, but they show you that when they're done, they end up with the two triangles laying on top of one another. Then it says, as a result of the transfer, B and E are in the same place. Okay? Because, and again, we'll get there in a minute, but it has to do with the fact that A and B are the same length as D and E. So when you put A on top of B, then A on top of D, then B is going to land on top of E because they're on the same ray and the same length away. And then lastly, they say the same thing about what is the justification? Why does F have to be in the same place? Okay, well, it's not about distance because that's this one. This one we don't have any distance. Okay, CF and F are the intersection of the same pair of rays. Okay, well, that ray and that ray are intersecting in the same spot. So that ray and that ray are intersecting in the same spot. Okay, that's why. Second one. Again, we have two triangles. Clearly, they've marked that all three sides are congruent. They're going to map this one onto that one, probably by a translation and then a rotation. So again, they just show us, hey, I mapped one onto the other. That's what they show me. Then it says if C prime and F are on the same side of DE. So if C prime and F are on the same side, so that's if they got to the same place, then if they're on the same side, then they have to be equal. And that's because they're both the equal distance from there. All right? If C prime and F prime are on the opposite sides of DC, so they're over here. Okay, so now it's saying, well, it's not on the same side. So in order to make that happen, they've got to reflect it over. So it's either they got it there in one move, or they had to slide it over and then flip it over. So they're not saying for certain which one they did. And then it wants to know what's their reason. Well, it's not the rays when that was the last one. And it's not that they're the same distance along the same ray. It's actually, if you look at the picture, it's the idea of the circle. Okay, because if I drew a circle here, it would be the same radius. So that's actually the one here. And it's C, F, and lie on the intersection points of circles centered at D and E. Okay, that's the reason why, because you have a center circle D and a center circle at E, and you draw the circles and they overlap. Again, that's probably the most confusing one. That's a hard one. It really is. Okay, now, here we go again. They told us one side is equal. They told us then two angles are equal, so we got angle, side, angle. They're going to map it again. And then they want to know, how do we show that the triangles were congruent? Well, did we show all corresponding sides have equal lengths and all corresponding sides have equal measures? That's not how they really did that here. We mapped one figure onto the other using rigid transformations, and we mapped one figure onto the other using any kind of transformations. Well, we need rigid transformations, so we mapped one onto the other using rigid transformations. What did we show were congruent? Triangles with two pairs of corresponding angles have the same measure and included corresponding side have the same length, or triangles with two pairs of corresponding angles have the same measure. Well, we had two corresponding angles and an included side. That's that angle, side, angle thing. Okay. And then the last one, we're doing it one more time. So we're doing angle, side. We're doing side, angle, side here. We're going to turn this one into this one. Again, they're going to use some transformations. They're going to slide it along. And it says, what fact can we justify can we use to justify step one? So how can we say, okay, we know that if we map it over that E and B are going to be the same in the same spot if we do that. If A prime is the same as D and B prime is the same as E. What is our justification? And it says A, B, and D, E are segments with the same length, are congruent. B, C, and E, F are segments with the same length. Well, B, C, and E, F may be, but that's not what we're talking about. We're talking about A and D and B and E, so we're not talking about this one. And then we weren't even talking about angles. So the reason we can justify it is because they are of the same length. Okay, now, I think that was a pretty tough one, but hopefully that helps. All right, this one's going to be a little bit easier. We want to know, are the two triangles congruent? Well, this gets into, they were talking in there about the different types of congruency. And so basically you have 5 ways to prove congruency. You can do side, 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 angle, side, angle, side, angle, or side, angle. And the last 3 are actually all the same one. So really you have 3 ways to prove congruence. You have 2 ways not to prove congruence, which is angle, side, side, or side, side, angle, which are the same thing. That one is not true. Angle, side, side. I always tell people, spell that out. Never use that one because you'll make a blank of yourself. Okay, that's one. And then the angle. Angle proves something called similarity, not congruence, because you can grow or shrink the triangle. So what we're basically looking for is, do we have side, side, side? Do we have side, side? Or do we have angle, side, angle? Or some version of the last one where we can mix it up a little bit? Well, this one, we have sides that match. We have side that matches, and we have the angle in between. This is classic side, angle, side. So yes, these are congruent. All right, now here we have all the angles are equal. That's the one I was just talking about a minute ago. Angle. Angle does not show congruence. Now, it doesn't mean they're not congruent. They could be congruent. We just don't know. We have no reference to the side. Now, if they told me this side was 3 and this was 6, then I would know they weren't congruent. But I don't have enough information. I know they're at minimum similar, but I don't know for certain if they're congruent because I have no side references. In order to talk about congruence, you're going to have at least one side being equal. So there's not enough information. All right? Okay, side, side, side. I'm told that side matches, that side matches, that side matches. Side, side, side is congruence. Those are congruent. All right, side, side, side. Side matches, side matches, side matches. Side, side, side. Those are congruent. All right, now this is the one. Angle, side, side. That's the bad one. Okay, now again, could they be congruent? They could be. There's actually a special case in angle side side called hypotenuse leg. If that happens to be a right triangle, they are congruent. But we just don't know. Again, there's not enough information. We weren't told enough to know for certain they weren't. We weren't told enough information to know that they certainly were.